So, good morning today. We are actually going to solve problems involving calculus. Yes, so we are going to actually deal with calculus, differential calculus, particularly from first principle. And we are going to take the concept of trigonometry. We are going to see how trigonometry are differentiated using first principle. So we have a question on the board here with which we are asked to find if f of x is equal to sine x. We are asked to find the f prime of x using first principle. Now always remember that the f prime of x using first principle is the limit where h tends to 0 of f of x plus h minus f of x all over h itself. So now applying this principle, now remember that since f of x here is sine x, then my f of x plus h would then be what? Sine of x plus h in one sense. So having known that, now the f prime of x here now becomes the limit where h tends to 0 of sine x plus h minus sine x all over h, so that the f prime of x here becomes the limit of h tends to 0 of, now in this case, now you will realize that, remember from your concept of addition formula trigonometric, that the sine of a plus b is equal to the sine of a, the cos of b, plus the cos of a, the sine of b. Yes, no doubt. So applying such here now, you have the sine of x, the cos of h, plus the cos of x, the sine of h, minus the sine of x now, all over my little increment in x. So the next thing then becomes the f prime of x here becomes the limit where h tends to 0 of, now let's factor out things. Bring the sine, the one of sine x together. We have the sine of x, the cos of h, minus the sine of x, plus cos of x, sine of h, all over h. And so the f prime of x becomes the limit where h tends to 0 of, now let's factor out this. I realize that this one has a sine x, likewise a sine x here. So getting know that sine x is a common term, bring out sine x. Now we are left with cos x here. I left with cos x here minus 1 all over h. Do you know that is the same thing as saying plus the limit where h tends to 0 of cos x sine h over h. Now this theorem here, we have just applied the addition, yes, the addition law here under limit law. So that says that the limit of addition is equal to the sum of the limit. You understand? Or the addition of the limit is equal to the sum of the limit. That was what we are having here. So having known this one now, the next thing to do is, looking at this now, we'll realize that the f prime of x here is going to be, now look at this particular thing here. There are some rules, there are some concepts that speaks, there are some rules of limits. Yes, there are some rules that limits here takes. So one of the rules I'm going to show you now, there's a rule that says, or take note that the limit of h tends to 0 of cos of h minus 1 over h is equals to 0. Likewise, the limit of h tends to 0 of sine of h over h is equals to 1. So applying the rule here becomes, if we apply that rule here, we are going to have, let's see what we are going to have. We are going to be having the f prime of x here to become the limit where h tends to 0. Yes, I'm going to apply the product rule. You understand now? The product of a limit is equal to the limit of a product, and that's exactly what we are going to discuss here. So that the limit of sine x, the limit where h tends to 0 of sine x, times the limit where h tends to 0 of cos h minus 1 over h plus, are you with me, the limit where h tends to 0 of cos x times the limit where h tends to 0 of sine h over h. So applying, taking note of this, what we have here, we have that the f prime of x becomes, now the limit of h tends to 0 of sine x is sine x times the limit of h tends to 0 of cos h minus 1 over h is 0 plus the limit of h tends to 0 of cos x is cos x times, now the limit of h tends to 0 of sine h over h is 1, don't forget, so that the f prime of x here is equals to cos x, and that's our required solution. So we have just succeedingly find or differentiate sine x using first principle other than using your normal formula. So let's take another one. Yes, let's take the cosine of this theorem. We can actually take the cosine and do the same thing. So I will assume that if f of x is cos x and we ask to find the derivatives of cos x using first principle. So remember the formula. The formula says the f prime of x, the differential of the function in question, is equal to the limit where h tends to 0 of f of x plus h minus f of x all over h. So if I assume my f of x is cos x, then my f of x plus h would then be cos of x plus h, no doubt. So that I can be having f prime of x to be equal to the limit where h tends to 0 of, now I will replace my f of x plus h now with that value here, which is cos of x plus h minus my f of x, which is more or less my cos x over h. So from here now, always remember also that we have discussed something on addition and subtraction of trig formulas. So that means if we have cos of a plus b, it becomes the cos of a, the cos of b, minus the sine of a, the sine of b. Yes, no doubt, we are familiar with this kind of formula. Now, using that formula, applying the formula into the context of this this equation here, we have the f prime of x is equal to the limit where h tends to 0 of, now apply it here, we have cos x cos h, are you with me now, minus sine x sine h minus cos x all over the little increment in x. So then the next thing is the f prime of x is equal to the limit where h tends to 0 of, now limit where you turn h to 0, remember we can actually, there's a common term here, we're having cos x, let's bring them together, and we have the cos of x, cos of h minus the cos of x, now minus the cos of x minus the sine of x, the sine of h all over my h. So that my f prime of x becomes the limit of h tends to 0 of cos x open bracket cos h minus 1. Since cos x is a common term, yes, you realize that cos x is common, minus the limit of h tends to 0 of sine x sine h over h. Yes, so that my f prime of x becomes the limit of h tends to 0 of cos x times the limit of h tends to 0 of cos h minus 1 over h minus the limit of h tends to 0 of sine x of sine x sine x sine h over h. So that this one becomes f prime of x is going to be, now if you take the limit of h tends to 0, sorry, this one becomes, you can actually use this, can use something like this, times the limit of h tends to 0 of sine h over h. Yes, let's apply the rule. The product of a limit is equal to the limit of a product. So now the next thing is substituting h. Now taking the limit of h tends to 0 of cos x is cos x times, we have done something in something like this in our previous video, that the limit of h tends to 0 of cos h minus 1 over h is 0 minus, now the limit of h tends to 0 of sin x is sin x. Likewise, the limit of h tends to 0 of sin h over h is 1. So that the f prime of x here becomes cos x times 0 is 0 minus sin x. So this is the required solution for the differential of cos x. Now please don't forget to like, share and subscribe. If you have any message, any question, just don't forget my comment section is there. Make sure you drop my messages there. Don't forget. I love you all. Thank you for watching. Please don't forget to like, share and subscribe. Thank you.